Okay, we're going to talk about H9C, Matrix Powers Investigation. This section of the textbook is just going to explore with many of the properties that we see with matrices, and that's what we're going to do. So after this first example, I'm going to do most of my matrix practice using the calculator. Okay, so first question, they get you these matrices. Okay, using the fact that a squared is a times a, show that matrix a squared is not equal. Okay, so a times a, so here's matrix a, 2, negative 3, 4, 7, and I've just written it twice. And as we know, to get each value here, multiply for this here, I'm going to multiply this row times this bottom. So I'm going to have 2 times 2 plus negative 3 times 4. And then, so 2 times 2 is 4, and 4 plus negative 12 is going to give me negative 8, and so on. So you can check your work here. Here I have 4 times 7. So because this is the second row first column, so I'm going to multiply the second row times the first column. So 4 times 2 gives me 8, and then 7 times 4 is going to give me 28, and together that gets me 36. Okay. And then, so I'm trying to compare negative 8, negative 27, 36, and 37. And as we can see, that is not equal to what they gave here. So that doesn't. So when you square something, that doesn't mean you just square these values. Okay. So now they want you to explore and square, do b squared. So b is 2, 0, 0, negative 3. And notice how we get this. So I'm going to type this into my calculator here. So I've got second matrix, and then I'm going to arrow to edit. If you already don't have notes on it, let's write the notes down now, right? Okay, you push second x to the negative 1 to get to the matrix, right? Then you arrow over to edit. And then you type in your matrix. So I'm going to enter matrix B. Matrix B is a 2 by 2, so I hit enter. And then, so I'm going to change this to a 2 by 2. And the matrix is 2, 0, 0, negative 3. Second mode to quit. And now I'm going to do matrix B squared. So I can do second x to the negative 1. I'm doing matrix B, which is that 2 by 2 that I just entered, and we're going to square it. And so we get 4, 0, 0, 9. Okay, so like I said, I'm just going to be using the calculator from now on to do this. So if I do c squared, we get this, and if we do the identity matrix 1, 0, 0, 1, we end up with the identity matrix again. So notice this. That's interesting. That's what we're going to be looking at for this lesson. Oh, super important. Question number 7 is going to be super important for the beginning of the next lesson. So if you want to just forward to the end, hit pause, whatever. This is super important. But we're going to talk about that at the end of this lesson, and we'll talk about it at the beginning of H9D. Anyways, okay, second page. Okay, so if H matrix A, B, C, D, under these conditions, when is it going to be this squared plus the squared plus the squared plus the squared? When is that going to happen? Now we know that didn't happen when I had 2, negative 3, 4, and 7. Just random numbers. This is not going to be that each of these values is not going to be squared like this, right? we're not going to have 2 squared, negative 3 squared, 4 squared, 7 squared. However, it did work when we had 2, 0, 0, negative 3, right? When we did our matrix multiplication, we got 4, 0, 0, 9. So in a general situation, when is it going to work? And it's going to work when this value here and this value here is 0. Because if I multiply this row times this column, I'm going to get a times a, which gives me a squared, and 0 times 0, which gives me 0. So that's going to give me that cell there. Okay. If for this one here is first row, second column. So first row, second column is a times 0, and then 0 times d is going to give me that. So whenever you have zeros here and here, when I square it, it's going to be simply this value squared and this value here squared. Okay. Okay. So the only non-zero elements lie on the main diagonal. Okay. So if we've got this matrix D, so that if we're applying this rationale, then D squared would be 4001, D cubed would be 800, negative 1, D to the fourth would be 16001, so D to the k would be 2 to the power of k, 0, 0, 1 to the power of k. Okay, so as long as the a value is not equal to 0 and anything to the 0 power is 1, it's reasonable that if I have a matrix to the 0 power, that we're going to get the identity. Okay. So that's what we just practiced around and noticed and wondered. This is the general situation. Okay, so now we're going to do a few examples. So they wanted you to complete the exercise and multiply these things. So and see if it's possible or why. So if I have matrix A times matrix B, so this is this matrix and this matrix. So first of all, we know matrix A is a 2 by 3 matrix, and matrix B is a 2 by 2. So we automatically know that we can't do this multiplication because the number of columns on the first matrix does not match the number of rows in the second matrix. The number of columns of matrix A does not match the number of rows of matrix B. Okay, now if I switch it around, I've got a 2 by 2 matrix and a 2 by 3 matrix. Those do match this and this, so now we can multiply it, and I did this using my calculator. Okay, and we know that this is not going to work because if I've got a 2 by 3 matrix and a 2 by 3 matrix, this one here doesn't match there. So basically, if I'm going to square a matrix, it needs to be a square matrix. It needs to be, either a 2 by 2 or a 3 by 3. Or 4 by 4 or 5 by 5 or whatever. So it needs to be a square matrix that would look like this. Okay, so matrix B squared is if I got this and this, and like I said, you just type it into your calculator. Okay, so for the rest of the packet, or most of the questions, 2 through 6, they wanted you to use these matrices. So what I did is I plugged in all of these matrices into my calculator. I just simply let's see, 0, -1. Okay, that's in there correctly. Let's check. We know B I just changed. So I called, so R, S, T, U, W, X. I just put this in matrix A, B, C, D, E, F. So matrix B, this is a 3 by 3, and 3, -2, 1, 4, 1, -3, -7, 5, 2. Second mode to quit. All right, let's look at matrix 3. 2 by 2, is that 1, 2, -1? Okay, good, that matches. Matrix 4. 3 by 3. Yes. Matrix E. Oops. Okay. Pretty sure I have all these in there right. F. Okay, good. So I've entered in all these matrices in matrix A, B, C, D, E, F. Okay. So the first one here, S to R. So matrix S, so matrix B, and matrix R, so B and then A. So I'm going to multiply matrix B times matrix A, and we get this value. And then T and R. So matrix T is a 2 by 2, and matrix R is 3 by 2. So that's not possible. Okay. W, R, and X. So if I multiply W times R, I'm going to get this guy. And if I add this guy plus this, I'm going to get this value. Okay. S minus U. Okay, so question D is W times parentheses S minus U. So first off, I did S minus U to get me this guy. And then I do W times S minus U. And then I multiply it across and I get this. E is not possible because the number of columns doesn't match. Okay. Question number 3. U times R plus R. So if I do U times R, I end up with this matrix here. And if I add R, I'm going to get this. Now if I do U plus I, I'm going to get this. And if I have U plus I times R, we get the same thing. So let's think about this. What does this mean? Okay. So R times U is going to give me UR. R times the identity is just going to give me R. That's what's happening. So whenever you multiply a matrix times its identity, you're going to get that matrix again. When you multiply this matrix times that, we're going to get UR. So basically what we just said is if I have UR plus R, that's going to give me the same thing as if I multiply this using distributive property. This is what they wanted you to experiment with. Okay. And then question number 5. SU squared, so I multiplied S times U to get me this. And then I square these values. I just put this into the calculator. Here, let me show you what I did. I think that's a useful thing for you to see. So matrix S is B. So second matrix B. Okay. times U. U is matrix D. Enter. So when I multiply S times U, we get this. And if I take this answer and square it, it gives me this matrix here. Okay, so now if I square matrix S, we get this. If I square matrix U, we get this. And I did this using my calculator. And I got S squared times U squared gives me this. And so as you can see, these are not equal to each other. Okay, so show that 2 times RT equals 2 times R times T and equals R times 2T. So you can check your work here. Now, number 7, the one that I think is most important. So we have -3, 5, 1, and -2. We got that matrix here. B is -2, -5, -1, -3. Okay, if I multiply those together on my calculator, we get the identity matrix. If I switch them around and do matrix B times matrix A, you're going to end up with an identity matrix. So this is very important. So there's certain characteristics of A and B that I want you to notice. Notice the -3 and the -2. Those values have been switched. Isn't that interesting? And notice the 1 and the 5. Oh, it's the same numbers. Oh my goodness, but they are negative. I wonder what that means. I wonder this relationship. I'm excited to look at H9D now. Okay, but before we do that, let's do question 7b. So 2 times AB. So we know that AB is going to give me 1, 0, 0, 1, right? Multiply that by 2, we get this. And then this to the 10th power is going to give me this. I'm so excited to look at H9D now.